welcome back to my YouTube channel. So in this tutorial we are making this age and gender classification using Opencv and Python, and this is the most highly requested video from my YouTube subscriber. Even though some of them comment in my comment box and also message me on my Instagram. And one guy, he from India named Naveen Kobar, I want to mention him. Okay, he requested me to make this video, so that's why I'm going to make this one. So please watch the video till the end because it will be awesome. Let's get started. This is Mishudo Chandu and welcome back. So first thing first, I want to say one thing, that is, if you are new in my channel, so please do subscribe my channel and must hit the bell icon. And so if you wanted to do this project in your local machine, so you need to do some installations and do some processing you need to follow. So first thing first, you need to install Python in local machines, and also you need to install a package or a library, whatever you call, Opencv. Okay, so just open your command prompt and type here the pip install, and the library name is Opencv Python, and enter. So if you're using Linux or MacBook, so just open your terminal, okay, and just type here sudo apt pip install Opencv Python. So as you can see here, requirement already satisfied. That means this library is already installed in my system. So one thing I want to mention, that is, please install this latest version of Opencv, because this project only run on the its version is greater than 3.4. It will load, because we are dealing with some deep learning technique, so that's why we're going to use the latest version of Opencv. So I'm going to click here to close this. So let's jump on our working directory. So this is our working directory. As you can see here, there is some model file. Okay, so model file, as you can see here, age deploy, and this for model file for the age directions, and there are some model file for the gender and the model file for the face directory. You can also use the hair cascade to redirect the face, but it's better to use this model file because we're dealing with the other model file. As you can see here, age and the gender, so it's better to use this model file. Okay, so I'm going to open here this Visual Studio Code. Okay, so our Visual Studio Code is open, so you can see here age and gender direction. This is the folder name. So I'm going to click here and create a new Python file. So now what we need to do, we need to import the CBT module, because we are going to use Opencv. So you know, when you deal with the Opencv or image pre-processing, you need to use this library. And because we're dealing in the real time, so that's why we are going to create a video capture object, or whatever call you can camera. Okay, so I'm going to first import cb2, and I'm going to create a video capture object. So video equal cb2 dot video capture. So inside this parameter, it take a argument. So I'm going to put here 0 because I'm going to use my laptop camera. So I'm going to click here to close this, and let's create a infinite loop. So true, and let's say ret frame, not a frame equal video dot read, and cb2 dot imshow. So this one help us to show our frame. So you need to put here the window name. So let's say window name age, gender, whatever. Okay, you can. So and put here the frame, and now we need to put here a wait key, which will help us to wait our frame in a pop-up. So wait key. So inside the parameter, you need to put here 1 because we are going to iterate in an infinite loop. So if k equal ord, and if anyone press q, so this infinite loop will be break. So video dot, we want to release our video, and also destroy the all windows. So destroy all windows, and click here to run the code. So now you can see here this pop-up will open. Okay, so our camera is done. It will take 1 minute, okay, to make this. Okay, so when I press Q, so this infinite loop will be back. So now we need to load our model. So first thing first, we need to detect our face. So after detecting our face, we can measure our age and the gender. So now we need to load our model. So inside this this document.txt, you can see here the path of the face model and the prototype. Okay, so for the time consume, I am going to copy this. Okay, so I'm going to paste it here. So this is the path of the face product and the face model. As you can see here, this is the Opencv face detector. Okay, this is the PB file and this is the PBTX file. Okay, so we're going to use these to detect our face. You can also use the hair cascade, so it's up to you, but it's better practice to use this model file. Okay, so now what we need to do, we need to create load our model. So we need to create a variable called the face net. Let's say face net and cb2.dnn. So DNN is nothing but a deep neural network. So it will be the latest version of Opencv. If you're using Opencv, let's say 3.1 or 3.2, so you don't get this one. If you're using the latest version of Opencv, you can get this functionality. Okay, so not this DNN buffer image. So you need to put here the read net, not the blob. Okay, read net. So inside this parameter, you need to put here the model first. So face model. I'm going to put here the face model and the product file, the face and the products. Okay, so now there is some procedure, okay, we need to follow. So first we need to read our model. Then after reading the model, we need to create a blob. Then after creating the blob, we need to put the blob into our set input. Then we are going to pass the network in our forward. Then we are creating a rectangle and detect our boundary boxes. Okay, so let's define a function to do this all thing. So let's say face box. So first thing first, we need to create a blob. So blob is nothing but the binary long object classification. Okay, so cb2.dnn. so inside this dnn there are two functionality. First one is a blob from image and the blob from images. So we are going to use this blob from image. So it will take some argument. So first one is the images. So our parameter will take first the frame. So let's put it here, the frame. So we are going to pass this frame from here. Okay, so I'm going to pass the first frame. Frame means it's our image. Then it will take the scale factor. So let's put here the scale factor 1.0 and it will take the size. So what would be the size of our image? So our model is trained up by 227 cross 227 images. So that's why I'm going to put here 227 cross 227. And then it will take the mean. So what is the mean? If you know the CNN technique or of the means of extraction, so this is the mean of that. So the actual mean value of the RGB image is nothing but for the red channel is nothing but 103.66. So approximately you can say here 104, I mean 104, and G value is nothing but 116 points something, but we can put it down here 1017, and the G value is nothing but the 123. Okay, so we need to put here the approximate value. So we need to memorize this one. So 104 and 117 and 123. Okay, so I collect this number from a particular website. This website from the PyImage source. You can just go on the Google. Okay, this is the particular website. Okay, you can see a deep learning how Opencv's blob from images work. So you can read this documentation. You can see here blob from images and image. How can we perform this? There's two functional perform. First one is the means of extraction and the scaling factor and the optimally channel. So you can see here deep learning and the means of extraction, how it is work. Okay, you can see here R value is nothing but 124, 115 and 106. It's actually in some images it will be changes. Okay, don't worry on that. But if I go down, you can see here for example the mean value of the image net. So we're going to image net training set. So R value is 104.93 and G value is 116.77 and the B value is 123.68. So we take the approximate value. So don't worry on that. I'll put this block link in the description. You can also read this. Okay, so you can see here, read that. Okay, so let's go our code. So now it will take the parameter. What is it will take the parameter first. It will take we give the mean. So now the swap RB. So by default it none, but let's put it here false. Swap RB equal to, let's say, false. So it will read the blob from the images. So let's put into a variable. So blob. So we need to put here the frame. Frame is taken here from the parameter. Okay, so now we need to set the input, okay, from our blob. So let's put it down here. Let's put here variable nat equal to cb2 dot cb2 dot. Okay, so it will take the parameter of the nat, so we need to also pass it here. Okay, face nat. So this is the face nat, we are going to pass it here from there. So let's put here face nat dot set input. Okay, so this set input will take the blob image, so blob, and also we need to put this blob into the forward method. Okay, so this forward should be the face nat dot forward. Okay, so so let's put into a variable called detection. Okay, so let's try to print it out, print the detections. Okay, and let's call the function from here. So let's call it. Okay, we need to return something here. Okay, let's say return return detection. Okay, so let's see here, and let's say detection, or let's say detect equal to, let's call the function for the face box first, and put here the face net and the frame, and let's run our code. So as you can see here, it will give me an array. Okay, give me an array. So you can see here, when I run this code, you can see here it is a long array, multi-dimensional array. So I take a part from here and save my file. Okay, maybe matrix. Yeah, so you can see here I took the detection part and take a matrix from here. So you can see here it is a nested list. Okay, as you can see, click here. So first this one, the first one, second one, third one, and the fourth one. So this is the detection part, detection matrix. So first one is nothing, and the second one is the classes. Okay, for the confidence type, and this one is the confidence value, or you can say the prediction accuracy. Okay, or you can say probability. Okay, so we need this confidence value. Okay, so we need to extract this value. So now we need to create a loop and loop through this from the detections and create a for loop. Then we can get this confidence value from this detection matrix. Okay, so if I try to print the shape of the detection, so shape, save it, detection dot shape. Okay, so you can see here the shape is nothing but 1, 1, 200. So we need this 200. Okay, so I am going to loop through this shape. Okay, so I'm going to remove that. So I'm going to create a loop to loop through this and get this predicted value from the confidence value, and we are going to create the bounding box. Okay, so for I in range, I'm going to create here the detections dot shape, not a detection dot shape, and the parameter you need to put inside this list, you need to put here 2, because we are going to, if you see here, if I run the code again, run the code. Okay, so you can see here 1, 1, 2, 2007. So this is the first index, 0, 1, and 2. We need this value, so that's why I put here this one. Okay, now we need to calculate, or we need to collect the bounding boxes from these detections. Okay, so let's grab the confidence value from the detection. So if I go here, this is the detection matrix. If you run this detection matrix in your kernel, so you can look like that, a multi-dimensional array. So we need this confidence value. So this confidence value is nothing but this it is a nested. So first 1, 2, 3, and the fourth one. So if I going to collect this one, we need to go to this nested list. So I need to go here to detections. So let's put it here as 0 comma 0 comma I comma 2. Okay, so why 2? Because we are first we go to the 0th index, that's means 0th index, and again the 0th index, and 1 is nothing but this kernel, because this matrix is multi-dimensional, and we are going to collect this one. So that's means 0, 1 and 2. So we get this confidence value. So this is our confidence value. Okay, so I am going to save this value in a variable. So let's say confidence. So I'm going to save this value in a confidence. Okay, so if the confidence value is greater than 0.7 or 0.8, then we are going to create the bounding boxes. So if the confidence is greater than 0.7, we are going to create the bounding boxes. Okay, so the bounding boxes is nothing but there is some frame and the white. We need to create that. So first thing first, we need to calculate the shape of our frame. What will be the shape of our frame? Then we need to cut the faces from here. Okay, I think it will make sense to you. So detections and 0 comma 0 comma I comma 3, and you need to multiply with your frame width and the frame height. Why? Because if I go here inside the detections matrix, you can see here these are some values. Okay, this values is nothing but the width, height. Okay, or you can say start x, start y, and the end x and the end y. So these are all the value in a normalized mode. So we need to calculate that, and we need to, after calculating that, we need to subtracting all the values from here. So we need to multiply the detection part of this frame into the frame of width and the frame of the height. So let's put it here. So let's say frame width. So the frame width, that means the width of our frame. So frame dot shape. So width is nothing but the 1, and the height of our frame dot shape 0. Okay, so this is our frame height and width. Okay, so if I trying to print this out, okay, if I trying to print this out, okay, frame width and frame height, let's put it down here, print the frame. Okay, Control S and going to save this, run the code. Okay, so you can see here, okay, this is the frame. If I go, we are printing the frame. Okay, we are printing the frame. We need the height and the width of the shape of the frame. So it is our height and the width of the frame. Okay, we're going to calculate that. So our 0th index is nothing but our frame height, and the shape one is nothing but our frame width. Okay, we're going to calculate this one. So the x1, or you can say start x, is going to be multiplied by frame width. Okay, so frame width. Okay, and let's put into a variable, let's call x1. So this one our start x. Okay, and now we need to typecasting it into integer format. Okay, integer, this one, and our y is nothing but the height. Okay, let's copy it from here, Control C and paste it here. Okay, so this is our y1, this is our x2, and this is our y2. So this should be the 4, and this should be the 5, and this should be the 6. So that's mean this is the start x, and this one is the start y, that is y coordinate, and x2 is the end of x and the end of y. So we get the bounding boxes. Now we need to append in a list. Okay, it's better to append in a list. So let's create an empty list, bb box. So we are going to append all the value from this list. Okay, so bb box dot append inside this link x1 y1 and the x2 comma y2. Okay, so we append this value from here. Now we need to create a rectangle to detect our face. So cb2.rectangle, and inside this you need to put here some arguments. So first one our frame, and the second one is the x1 comma y1, and the point 2 is nothing but the x2 and the y2, and you need to put here the color. So let's put it here green color 2550, and let's thickness as 1. I'm going to save this and I'm going to run the code. So as you can see, detect my face, okay, in a long way. So we need to do some changes on that. So this will not be the frame width, so this should be the frame height. So frame height, and it also same in this case. Let's save it and run the code again. So as you can see, it detect my face correctly, okay, correctly. So now we need to detect and load our gender and the age model. Okay, I go slowly because it's very important, okay, to understand this technique. Okay, so we are going to return the frame from here, frame for the this one, and we are going to also return the bounding boxes. Okay, these bounding boxes we are going to return. Okay, let's make it as boxes because there are so many things, boxes. Okay, so now we need to load our gender and the age model. I'm going to go here, and this document.txt, I'm going to copy this one. So let's load the age and the gender model. So let's say, let's copy it from here. Okay, don't need to copy. Age nat equal cb2.dnn.readNat. So inside this you need to put here the age model and the age products file, and also do the same for the gender. Gender nat equals cb2.dnn.readNat, and you need to put here the gender model and the gender products. Okay, so our read nat is done. We load the model, we read the model, but we don't load it yet. Okay, so now we need to specify some list. Okay, let's go here, document. So this is the model mean value. We need to use this. So first use this one for the age list and the age collector. Okay, so this is the age list. I am collecting this age list from a Google image. Okay, so this is the range of the what do you call this age, and a list of the gender list. So first one is for male and the second one female. Okay, so now we need to call the function from here. We already called this, but it will return two variable. Okay, so we need to also give here. Okay, so first one is the frame and the second one is the bounding box. So now we need to iterate through all the bounding box coordinate from here, and we are going to create the bounding boxes and get our result. So now let's loop through all the value from here. So for bb, for box in bb boxes, so we loop through all the value from the bb boxes, that's mean bounding boxes, and we are going to extract the face from here. So I'm going to extract this face equal frame. So this is our frame, actual frame. Okay, we are going, we put here. Okay, let's put it here, the frame nat okay, frame net, and let's put it down here also, the frame net and the frame net. Okay, so frame net or frame whatever, okay, it will pass here and it will take the arguments, some arguments. So first one is the bb box, the coordinate of 1 to bb box coordinate of 3, then bb box 0 to bb box 2. So bb box 1 means if I go up, okay, you can say bb box 1 means 0 means x1, 1 means y2, and x2 means 2, and x3 means 3, because we are going to the indexing part. Okay, so bb box, first we are going to cut the width and the height, then we are going to cut the face from the bb boxes, that's in bounding boxes. So 1 2 3, that's mean this should be the y1. So we go to the first start of y1 to a start end of the x2. So it will cut the width and it will cut the height, then it will give me the face. So now we need to pass the face from our blob. So let's put it here, a variable called blob, cb2 dot dnn dot blob from image, and take again the frame net. We are going to pass it here, the frame net, or you can also put it here the frame, it's up to you, no problem. So frame, okay, no problem, frame, you can also pass it here, or frame and whatever, but I am very better to use the frame, not use the frame net. Frame. Okay, so now it's also same as the scale factor, you need to put here the scale factor. So let's put here a scale factor 1.0, and the size of the images, so again 227 comma 227, and you need to put here the mean value. So if I go here, so this is the model mean value, we need to use this because this is pre-trained model we are using. So I am going to paste it here. Okay, so I'm going to call it here. Okay, so model mean value, and you need to put here the swap rb. So let's put it here swap rb as swap rb as false again. Then we need to pass this blob in our net. Okay, so let's pass it first in the gender net. So gender net, this is our gender model, this is our gender net, and first let's set the input for the gender net. So gender net dot set input, inside this parameter you need to put here the blob, and let's save the predictions in a variable to make this forward. So gender net dot forward, and let's put in the variable called gender predictions. Okay, so it will take the prediction of the gender net, and we are going to take the only the maximum value from these predictions. Okay, so gender equal gender list. So from the list we are going to access the class from this prediction part. So let's give here the gender predict. Okay, and the 0th index value, this will be the index value, and we are going to call the argmax for the maximum value. This argmax, this is the max, it will give you the maximum value of this list. Okay, so you need to do same as it is in the also the age. Okay, so let's put here the age net dot set input, and it will take the argument as blob, and also the age net dot again forward, and let's put in a variable called age pred or predictions. So I am going to copy, not going to copy that. So let's say age equal, so age list, and the age predictions and the 0th index and the arg max, max, the maximum value. Okay, so now let's create a label. As you can see before, when it will be detecting, it will inside what this frame, it will be a field and it will say male comma and the age range. So let's create a label for that. So we're going to use the format specifier, comma dot format, and it will take the gender first and the age. Then we are going to put the text over here. So put cb2 dot put text, and now let's put the text from here. So let's say frame and the label, and now we need to put here the bounding boxes. So bb box 0 and the bb box, let's put it here 1 minus 0 10, that's mean it will be up. And let's put here the font. So let's say cb2 dot font, let's put here the plain one, and let's put here 0.8 as the thickness, and let's put here the color. So color white. Okay, we're using the white color, 255 255 comma 255, and the thickness, so let's put it here 2. Okay, so let's close it. Okay, color okay, fine, we can run the code. Okay, oh, we need to make this a face, not frame. Okay, let's save it out and run the code. So you can see here, you take the face and it will say the male and the age range. Okay, I think it's better to increase the font size. Let's put it here simplex, better use the simplex one, the font simplex, and also let's put here linear. It's better to, it will increase the size of the font, linear. Let's save it and run the code again. Okay, so you can see here it will detect it quietly, but we need to also create a rectangle here. Okay, so let's create the rectangle with the field color. Okay, so let's say cb2 dot rectangle, and inside this you need to put the frame and the point 1 and the point 2. Okay, so point 1 is nothing but the 0, and you're going to subtract in the point 2 point 1 minus 30 because into the up version, and the point 2 should be the bounding boxes of the 2 and the bounding boxes of the 1. And also we need to put here the color. So let's put here the green color to again 2550, and the thickness, so we're going to put here -1 because we're going to fill it. Okay, let's run the code. Yeah, it's fine, working fine. You can see here it will detect in the face male and 25 by 25 30, this is age range. Yeah, but when I go here, oh, what happening? Okay, if I go and see, you can see a blob equal to cbt.dn and the blob. So this error from the blob, and it will say the ss size.empty in function cb.resize. Now why this program will crash? Why? Because I put here 227 comma 227 as the resized image, and I pass here the cutting of the frame as a face. But the problem is when I go up, the frame is decreases. That means it will not get the actual frame we put here 227 cross 227, because our model will take the size of the image only for 227 cross 227. So we need to make a calculation of that. So I already do that here. So this is the code. So I'm going to paste it here. Sorry about that. And I'm going to okay, comment out this. And also we need to initialize the padding. So what will be the padding of this resizing circle? So now you can see here it is detecting, but if I go down here, so it will not gone. Okay, so let's put some other picture, okay, from my mobile phone. Okay, let's use this one, Elon Musk. Male 48 to 53. As you know, Elon Musk's age is nothing but 49 maybe. Okay, so let's use the picture male person, my favorite actress Sudhir Kapoor. Yeah, female 25 to 32. He's nothing but 34 years old. So the model will give me correct output. Okay, so this is the tutorial. Hope you will enjoy this tutorial, and make sure to subscribe my channel, and don't forget to hit the bell icon for never miss an update. And I'll be back with another awesome content.